Hello. Every year, hundreds of thousands of cases of amputation due to injury, infection, and disease are reported. In the first world, replacing a limb is expensive, but subsidized by healthcare providers. In developing nations, and specifically for children in developing nations, replacing a limb can be very costly. We've developed a limb which is expandable and contractible, so it can work with children as they grow, which allows us to address multiple problems of development and decrease the number of prosthetics a child requires over the course of this development. With our current technology, we have the ability to change lives. Our device has been built from the ground up. This allowed for us to tailor the strength and shape we wanted for the limbs based on the needs of our target regions. The components were modeled so as to allow us to adapt the design at the request of a customer, giving us the versatility to meet any need. Once a design is finalized, we test digitally for all potential failures, from impacts to temperature-induced stresses.
Then all the parts were rapid prototyped for testing confirmation. Once this phase was completed, all the parts were laid out to be injection molded. This means the cavities are filled with plastic simultaneously in mere seconds and cooled inside the mold to control the part dimensions. The process is highly quality controlled and traceable. This method allows the parts to be mass producible and saves significant time and money. While our distribution locations do not require meeting FDA standards, our device meets all of these requirements, as we will not be accepting anything less. Although children are our primary customers, the organizations that provide healthcare and therapy are our main consumers. They will also act as our vendors, using their existing distribution chains to provide the end user with our devices. Our predicted cost per unit for our first 1,000 units is $20 US. We plan to create the Give a Hand Foundation, which will be funded by public and private sales and donations to provide underprivileged children with limbs. We expect approximately 15% of the upper prosthetic limb market in 3 years using our modern technology.
Coupling all this with an interdisciplinary team and advanced technology, we're able to produce the highest quality prosthetic currently available at this price point, which can completely revolutionize the prosthetics industry. I'm Jonathan Dialdiretti, mechanical engineer.
I'm Erin Keeney, plastics engineer.
I'm Brendan Donahue, history and mechanical engineering student.
I'm Sean Gibson, a mechanical engineering and business student.
And I'm Katie Kane, mechanical engineering and pre-law.
Design, develop, and deliver. We are Nonspec.